Now I am going to do the ammonia structure. How to write the structure of ammonia? Look at the board now. Ammonia structure I am going to do now, right now. Ammonia. So what is the formula of ammonia? Ammonium NH4, ammonia NH3. Don't get confused between ammonia and ammonium. Okay, NH3. NH3. So it has how many electrons in its valence shell? 5 electrons. It has 5 electrons in its valence shell. Now, so write in the middle there and next here write the valence electrons around that nitrogen symbol. Okay. So 2, 4. So 5. Okay. 5 dots around the nitrogen symbol. Okay. Next hydrogen. Hydrogen it has how many electrons? 1 electron. So here write into symbol. Okay, into symbol. How many hydrogen atoms are there? How many hydrogen atoms are there? 3 hydrogen atoms. Okay. So this is before combination. Before combination. So can you see the board? Can you see the board? Now look at that. So to the each corner, so 3 electrons are written. Okay, and 2 electrons are written separately. Like that only should write. Clear? Then these two are going to combine. These two are going to combine. So after combine, they are going to form so this is the structure of ammonia, or you can write like this. Ammonia, structure of ammonia. So this is after combination. After combination. After combination. Look at here. I written 2 electrons. Only 3 electrons they are going to share with the hydrogen atom, is it? And 2 electrons will be remain. So what it will cause? They are called lone pair electrons. They are not involving in the covalent bond, the formation of covalent bond. So that is a lone pair electrons. We call it as a lone pair electrons. Okay. So nitrogen it has 5 electrons in its outermost shell. Only 3 electrons they are going to share with the hydrogen atom. 2 electrons will remain. No, the 2 electrons they are called lone pair electrons. Okay. Now this is the covalent structure of the ammonia. Covalent bond structure of the ammonia. So few properties and comparison between the electrovalent and covalent compounds they gave in your textbook. You can see your textbook there. You can go through your textbook. Okay. Few comparisons are there that you learned in the what in the class only you learned there. So you can, if you want few more properties and comparison, you can go through your textbook. Clear? Now I am going to the next topic now. Effect of electricity. Effect of electricity on electrovalent and covalent compounds. Effect of electricity on electrovalent and covalent compounds. Effect of electricity on electrovalent compounds and covalent compounds. Okay, so just I'll write one diagram. Yes. Can you see the board there? This is the experiment setup. One beaker is there. Sorry, one large beaker is there. So for the total, we connected the battery. Bulb is there. This is the bulb. We connected to the 6-volt battery. Okay. One meter is there. So the current reading. Okay. And that is connected to the 6-volt battery. Clear? And bulb is there. And so this is there. This one. So that is the platinum wire. So platinum wire is dipped into the water. This is the water solution. Water or some liquid. Okay. I will tell in the next one. Explain what it is. Okay. So the one end is connected to the anode. Another end is connected to the cathode. Okay. So these platinum wires are connected to the positive end, and these from this side. So the cathode connected to the negative end. Anode connected to the positive end. Cathode connected to the negative end. Okay. And we are passing 6-volt battery here to show the current reading. Ammeter is there. Okay. And water solution. So what will happen? What is the effect of electricity on electrovalent compound and covalent compounds? So first one, effect of electricity on electrovalent compounds. Okay. So give some example for the electrovalent compounds. Yes, sodium chloride, magnesium chloride. Very good. So in the beaker, take the sodium chloride solution. Take the sodium chloride solution. Clear? Next, what? So take this platinum wire. The anode or cathode end. Okay. So what you are taking in the beaker, you are taking the sodium chloride solution. That is the electrovalent compound. Sodium chloride is the electrovalent part, is it? So in the beaker, you are taking electrovalent sodium chloride solution in a beaker, and the platinum wire is there. No, take that wire, dip into the that solution, sodium chloride solution. That time, what will happen there? Bulb will go. Bulb will glow. It means, so in the beaker you are taking sodium chloride solution, you are dipping that platinum rod, you are dipping into the sodium chloride solution. That time, so the bulb will glow. It indicates, so electricity will pass through the electrovalent compound. So it indicates electricity is passed through the electrovalent compound. Is it? So why this happens? Because due to the free mobile ions. It is an ionic compound, no? It is an ionic compound. Positive charge, negative charge is there, no? Ionic compound. Because of free mobile ions, there when platinum is dipped into the solution, sodium chloride solution, that time you can see the glow in the bulb there. So it indicates electricity is passed through the solution, sodium chloride solution. So from these you can conclude that one. So through the electrovalent compounds, electricity will be passed. Okay, they are going to pass the electricity. So is it? So this is about the effect of electricity on electrovalent compound. So it means ionic compounds or electrovalent compounds are good conductor of electricity. We can conclude that one. Ionic compounds or electrovalent compounds are good conductor of electricity. Ionic compounds are good conductor of electricity. Ionic compounds are good conductor of electricity. So because of free mobile ions, that is the reason. Free mobile ions is there now. So because of that reason, they are allow the electric current through that solution. When you pass the electric current through that one, they will allow the electric current. Next, effect of electricity on covalent compounds. Effect of electricity on covalent compounds. And sugar solution, distilled water, alcohol, chloroform, CaCl3, I told yesterday in class, carbon tetrachloride. These are examples for the covalent compounds. So in the beaker, take the sugar solution or distilled water or benzene or alcohol, anything. Okay. So covalent compound solution will to take there. Okay, in the beaker. So in the beaker now I am taking the sugar solution. Sugar formula, molecular formula of sugar solution. C12H22O11. That is the sucrose. Now in the beaker I am taking the sugar solution. That is the electrovalent compound. Okay. Clear? Now I am going to dip that one platinum wire, platinum electrode. I am going to dip the platinum electrode into that beaker. That time there is no glow in the bulb. There is no glow in the bulb. So it means what? It means what? No conduction of electricity. They are good conductor of electricity or bad conductor of electricity? Bad conductor of electricity. It means through the covalent compounds there is no electric current is allowed. They are not going to allow the electric current and pass through that one. So this is procedure. So that is the effect of electric current on electrovalent compounds and as well as covalent compounds. Why in covalent compounds the electric current is not allowed? What is the reason? Because covalent compounds contain only molecules, no ions. That is the reason. Covalent compounds contain only molecules, not the ions. Next, I will go to the next concept now. Coordinate bond. Coordinate bond. The third type of bond. First one electrovalent bond. Second one covalent bond. Third one coordinate bond. What is by coordinate bond? The bond formed between two atoms by sharing of electrons. Bond formed between two atoms by sharing of electron provided entirely by one of the atom. But they are going to share both the atoms. But they share the electrons. So coordinate bond nothing but the bond formed between two atoms by sharing a electron. By sharing a electron pair, they are going to form the bond. That sharing electron provided entirely by one of the atom. Whereas in case of covalent bond, so sharing means so two atoms also they are going to give the electrons, is it? But in case of coordinate bond, that is different. So they are going to form the bond between the two atoms by sharing the electron. Provided the sharing electrons provided entirely by one of the atom, but shared by both the atoms. That is called coordinate bond. Any doubt is there? The bond formed between two atoms. The bond formed between two atoms by sharing a pair of electron provided entirely by one of the atom, but shared by both the atoms. So they are going to form the bond between two atoms. They are going to form the bond, okay, by sharing the electron. But the sharing electron is there no, that is provided entirely by one of the atom. Two atoms are there. The sharing electron provided entirely by one of the atom. But that shared electrons are shared by both the atoms. That is called coordinate bond. And coordinate bond is represented by the symbol arrow. Like this. Coordinate bond is represented like this arrow. An example for the coordinate bond: hydronium ion and ammonium. Example for coordinate bond: hydronium ion. Hydronium ion, if you know the molecular formula, chemical formula, that one you can tell. Hydronium ion H3O plus. Hydronium ion. So this is the hydronium H3O plus. That is the hydronium ion. Okay. And ammonium, you know that already. Ammonium. Ammonium NH4 plus. These two are examples of the coordinate bond. Few are there, just I give two. Okay. So first one is the hydronium ion, another one is the ammonium NH4 plus. Clear? Example of the coordinate bond. So how to write this structure? I will tell you the will explain the concept that one. Okay. Next, some conditions are there for the formation of coordinate bond. For the formation of coordinate bond. So first condition, one of the two atoms must have at least one lone pair of electron. One of the first condition for the formation of coordinate bond, one of the two atom. So two atoms, they are going to form the coordinate bond, isn't it? So after that, one of the two atom at least have one lone pair of electron. One lone pair of electron. At least one lone pair of electron should be there. While writing the structure of ammonia NH3, I told that one lone pair of electron is Z. Lone pair not, lone pair. Lone pair electrons. Clear? So once again I will write here, get that. So this is the structure of ammonia, is it? So hydrogen, it will give one electron, and nitrogen one electron. So you know that in nitrogen there are 5 electrons in its outermost shell. So only 3 electrons they are going to share with the hydrogen. And so this is not involving in the bond formation. So that is a lone pair. So the first condition for the formation of coordinate bond is one of the two atoms must have at least one lone pair of electron. Please have one lone pair of electrons. So one of the two atoms at least have one lone pair of electron. The second condition, another atom should be short of at least a pair of electron. So another atom is there now. There should be short of one pair of electron. Another atom should be short of at least a pair of electron. Another atom should have at least a short of pair of electrons. So the first condition, one of the two atoms, so at least should have one lone pair of electron. The second condition, another atom. So two atoms they are going to combine, is it? Then they are going to combine. After the combining, they are going to form the coordinate bond. So first condition, one of the two atoms should have one lone pair of electron. The second condition, another atom should be short of at least one pair of electron. Okay, so these are the two conditions for the formation of coordinate bond. While explaining, I will tell that one. What is this lone pair of electron? What do you mean by short of one pair of electron? Okay. Next, the coordinate bond, that is also called co-ionic bond or dative bond. What it will call? Coordinate bond. It is also called dative bond or co-ionic bond. Dative bond or co-ionic bond. So dative bond or co-ionic bond. So why it is called dative bond or co-ionic bond? Because coordinate bond have both the properties of electrovalent bond and covalent bond. It has both the properties of covalent bond has properties of both covalent bond as well as the ionic bond. Next now, donor. So you will see two concepts here, donor and acceptor. Donor means what? Donor means the atom which provides the electron pair. The atom which provides the electron pair for the formation of coordinate bond. They are called donors. The atom which provides a electron. The atom which provides a electron pair for the formation of coordinate bond. Coordinate bond is known as donors. The atom which provides the electron pair for the formation of coordinate bond, they are called donors. Clear? Next, acceptor. Acceptor nothing but the one of the atom they are going to provide the electron. The provided electrons are shared by the another atom is there now. Other atom is there now. So what the electrons given by the donors, they are going to share that electron for the formation of coordinate bond. The electrons provided by the donors, that electrons, by taking that electrons, they are going to share the electron for the formation of coordinate bond. They are called acceptors. The atom or ion sharing the donated electron pair. The atom or ion sharing the donated electron pair. The atom or ion sharing the donated electron pair. Donated electron pair is called acceptor. Clear? So donors and acceptors. Donor nothing but the atom which provide the electron pair for the formation of coordinate bond. They are called donors, and acceptor, the atom or ion sharing the donated electron. They are called acceptors. Now, what is the effect of lone pair of electrons in oxygen atom? In oxygen atom also, lone pair electrons will be there. Effect of lone pair of electrons on oxygen atoms.